Hello everyone and welcome to this lecture in the hands-on large language models series. Today we are going to start coding using Langchain framework. It's going to be a very hands-on and a practical module, and I'm very excited to start showing to you the different capabilities which Langchain can offer to you. So first let me provide a quick recap of what all we have learned so far. We have learned that Langchain is a framework which allows us to chain different modules together and to make very powerful large language model products. What are these modules? Well, the modules can be model input output. They can be modules related to adding or removing memory for large language models. They can be modules related to retrieval mechanisms, and they can even be agents. Langchain provides a framework to put all of these models together, to assemble all of these models together, to build complex, to assemble all of these modules together to build complex LLM systems. So one way I like to think about Langchain is that you can think of it as an assembly line where multiple components are coming, and then Langchain is responsible for assembling these components together, and then what comes out as a result is something very powerful, something very strong. So all of this I'm just telling you right now. Now I want to show it to you. In the previous lecture we learnt about this first part, which is model input output, and we learnt about quantization. Today it's going to be a much more practical session where we are going to start looking at chains. So just as if you start building a house, there is a foundation of the house, right? Steel bars are erected on which the house is later built. So every big structure has a foundation. Similarly, if you consider Langchain, what is the foundation of Langchain? The foundation of Langchain is chains. And it sounds like a very simple thing. We are chaining different things together, but it offers a lot of flexibility when we are deploying LLM applications. And in today's lecture, we are going to look at chains, and we are going to look at two examples. We are going to look at a single chain first, and then we are going to look at something which is called as chain with multiple prompts. So that's what we are going to do later. I'm just going to call it multi-chain right now. Multi-chain. These are the two modules which we are going to cover today, and it will be a mix of writing on the whiteboard plus taking you to the coding interface to show you how the coding is done. Okay. So although we can use large language models in isolation, their true power is shown when used with additional components. Chains allow for extending the capability of large language models, and multiple chains can be connected together. For now, you just need to remember that chains extend the capability of large language model. If you are just a user of ChatGPT, you just go to ChatGPT and you interact with it. Then you don't need to worry about Langchain. But if you are a developer and if you are building or coding out an application on your own, you need a new interface. You cannot just do it without Langchain. Alright, so with that, let's get started with understanding the first application, and that is how to create a simple chain. So I want you to look at the framework here of how a single chain looks like. There is an input here. The input then goes to our chain, and then there is an output. Correct? So if you now zoom into the chain, here we will see what is happening within the chain itself. What you can do in this chain is that you can connect multiple components together which are finally connected to the large language model, such as you can have GPT 3.5, you can have Claude, you can have let's say Gemma, you can have any large language model here, and what comes before this large language model is some kind of a modular component. What is this modular component? as we explored at the top, this modular component can be a memory component, it can be a retrieval component, it can be an agent component. All of this might sound a bit complex to you right now, but don't worry. Today we are going to be starting with a very simple modular component, and let me use a different color for this. This simple modular component which we are going to start with is prompt. So what is a prompt? We have had several sessions on this before, but if I type on ChatGPT that what is the weather today, this is a prompt which I have fed to ChatGPT, and I am interacting with ChatGPT through this prompt. As you can see, this result has been generated for me, right? But now what we are going to do is that we are going to use the prompt as a modular component within a chain in the Langchain framework. So think about it this way, this bigger circle here is the chain, and in this bigger circle now we have a prompt which is the first link to the chain, and this prompt is then linked to the large language model. Why are we doing this? I'll come to that in a moment, but for now I hope you have understood the structure which we are going to code out in the Google Colab notebook today. So what we are going to do is that when we are looking at a prompt, we are not directly going to give the prompt. We are going to use a prompt template. The simplest way to think about a prompt template is that, let's say if you want to design a brochure, instead of starting from scratch, you will start with a template, because then you just change the heading, you change the subtitle, you change the footer, etc., and then the brochure is ready. You don't have to do the entire design again. It's similar with prompt template. Once you start with a prompt template, all you need to do is just change the text. Everything else remains the same. So every time you write a new prompt, you don't have to write the new template again. You just use the common prompt template and you change the text. Now, what is a prompt template? The main thing here is that when you are interacting with large language models through Google Colab, you cannot directly give prompts like you are giving it to ChatGPT. You need to give the prompts through a template. For example, let's say if you are using this large language model called Microsoft Phi 3. This is a large language model which is, let me actually go to the documentation of this large language model which we are going to use in the code today. It's this large language model which is Phi 3 mini 4K instruct GGUF, because it's quantized. Now, if we are going to interact with this large language model through Google Colab, we cannot just type in a prompt like this. We need to give the prompt in a specific format. So if you type Microsoft prompt 3 format, and if you click on create a prompt, this article will show you the way you have to format the prompt. But I have converted this into a schematic which is borrowed from the book Hands-on Large Language Model by J. Alamar. And here is the Phi 3 template. If you want to give a prompt through code to Microsoft Phi 3, you need to write it like this. First, you start with this bracket S, which is the beginning of sentence token. Then this slash user is the second part of the prompt, where this is what the user is giving. So let's say here you are writing what is 1 plus 1, right? That is the text which the user is typing. So you have to start this user and then type in what the user is typing, then give end. This is what the user has given. And then here is how the model output is revealed, assistant, and then here is the answer of the model. The answer to 1 plus 1 is 2, and then there is end. So this is the prompt template which Phi 3 expects. You have to start with this bracket S, then you have to type this user, then you have to type in the actual prompt. You have to type in the actual prompt, which is the user prompt, and then you have to give end, and then that's it. And then the assistant will provide the answer. So now the thing is, when you are interacting with Microsoft Phi 3, do we need to type this every single time we are giving the prompt? Not at all. We can use a prompt template. So everything else stays the same. The only thing which will change is the user prompt. So if you have already defined a prompt template, you just change the user prompt and then the prompt will be modified accordingly. The template will remain the same. So if you see this Microsoft prompt template, Microsoft Phi 3 prompt template, there are 4 components. The first is this elbow, which is the starting of the prompt. Then there is the user, which indicates the start of the user input, as you saw over here. Then we have the assistant, which you saw over here, which indicates the start of the model output. And then we have the end. So end indicates the end of the prompt over here, and here end indicates the end of the model output. These are the 4 components of the Phi 3 template. So overall, here is what we are going to do in the first part of today's lecture. This is the chain which we are constructing. The chain has a prompt. So this is a prompt, what I am highlighting right now, to the large language model. The prompt is defined in terms of a prompt template. So this is the template which we are using. So the user prompt is just getting filled in this part of the template, which is over here. And then the prompt is generated and then passed to the large language model, and then the output is constructed. This is how we are creating this chain in the Langchain framework. And now I am going to do this in code. So let's jump into Google Colab interface and let's create our first chain using Langchain. Before we get started, what you will need to do is just install Langchain and make sure that the version is greater than 0.1.17. I don't think you need to install OpenAI, Langchain OpenAI right now. You need to do that later. You will need the transformers datasets package. You won't need the sentence transformers DuckDuckGo right now. But if you are following this code, just install it once so that you don't need to reinstall these packages in subsequent lectures. And then most importantly, you will need to install Llama CPP. So let's see what this is, Llama CPP Python. If you see this, basically Llama CPP is the inference framework for large language models, which is written in pure C and C++. So earlier it only used to support Meta's Llama's models, but now you can do the inference with many models such as Microsoft Phi 3. You can think of this as the framework for running inference, which means we are giving the prompt to the large language model and the large language model is giving us the output. And the framework which we are using for this inference is llama.cpp. The reason it's called CPP is because it's an app which is, or a GitHub repository which is purely written in C, C++, and that's why it's very fast. It does not have any dependencies. It's not written in Python or R. It's directly written in C++, due to which it's extremely fast. It directly drops down to the compiler level. So if you see the number of stars on this repository, it's around 70,000. That's why this is a very popular inference framework. So you need to install Llama CPP Python and make sure this version is the same as what I am running right now, so that you will get the same results, 0.2.69. Alright, so once these dependencies are installed, what you have to do next is that you have to download the model which we are going to use. And the model which we are going to use, as I already told you, is Phi 3 Mini 4K Instruct FP16. Again, let me go to this model and tell you a bit more about it. When you see instruct over here, you should understand that it's an instruction fine-tuned model. That's number one. Number two, when you see this 4K over here, that's the context length. The number of tokens, the maximum number of tokens the model can see before it predicts the next token. And GGUF means that it's a quantized model. So probably we are taking the 32-bit and we are quantizing every bit down to 16 bits over here. That's what's happening. Let's confirm this. Yeah, we are using floating point 16, which means the weights of the large language model are quantized from their 32-bit representation to their 16-bit representation. Okay, so we are loading this large language model and it's on our system right now. Here you see when it loads, it takes about 7 gigabytes of space. If you don't use a quantized model, it will probably take higher or larger amount of space. But you need to make sure that this much amount of memory is free on your system for you to follow this tutorial. Okay, so now the model is loaded and our Llama CPP inference framework is also installed. So now we have everything in place to run the inference. So first let me just check whether Llama CPP is working. So what I'm doing is that from Langchain I'm importing Llama CPP. Langchain provides this package. And then what I'm doing is that I'm defining the large language model. So Llama CPP, and then in the brackets I'm specifying the model path. I'm specifying number of GPU layers equal to -1. So this means that we are not going to use any GPU. Let's test this. What does this mean? So n GPU layers equal to -1. Uh, n GPU layer specifies the number of layers in a neural network that will be executed on the GPU. Okay, so value of -1 actually indicates that all the layers of the model should be processed on the GPU. So earlier I mentioned that -1 indicates you are not using GPU, but that's not correct. N GPU layers equal to -1 indicates that all the layers of the model should be processed on the GPU. It's a default setting to maximize GPU utilization if the system has enough memory. So one more thing we have done here to make sure the computations happen on the GPU is that when you go to runtime, I have used the runtime type as T4 GPU. This will make sure that the computations happen on GPU, as is also mentioned in n GPU layers equal to -1. Max tokens equal to 500, context is 2048, seed is 42. This will make sure we'll get reproducible results. Alright, so max tokens in this context is the number of new tokens, maximum new tokens which will be predicted when you give a prompt. So when you run this will run, and then what you can do is that you can pass in any prompt to this large language model. So here I am passing the prompt that hi, my name is this, what is 1 plus 1? So let me run this right now. Alright, so when you have asked what is 1 plus 1, 1 plus 2, the answer which you get here is that the sum of 1 and 2 is 3. This question falls within basic arithmetic, which deals with numbers and the simple operations. Adding 1 to 2 yields 3. So that's the answer which we have got. This indicates that the large language model which we have loaded is working successfully. And now we are ready to implement the chain implementation through Langchain. So again, to refresh your memory, this is the schematic of what we are going to do today. We are going to chain a prompt with a large language model, and we are going to use a prompt template. So let's see. So first what we are doing is that we have to define the prompt template, and from Langchain we can import a prompt template. So here you can see I've imported the prompt template and I'm exactly following the Microsoft Phi 3. I have this, so let me show you /s. So you have the /s, then /user, which I have done here, /s user. Then you have the input prompt over here. So input prompt, this is a variable right now. This is the only thing we'll have to change when we define a new prompt later. Then we give end, and then we give the assistant, right? And then you define the prompt, which is a prompt template object, and then we pass the template and we have to pass the input variables. So the input variable will just be the input prompt which is given by the user. This is how you define prompt template. Now every time you need to define a prompt, you never need to write this entire template again. We just write it once. Only thing we have to change is this input prompt variable. Okay, now take a look at this statement over here. It's the most important component of the Langchain framework. Here we are creating the chain. See, we have already created the large language model before, and here we have created a prompt. So what we are now doing is that we are chaining the prompt with the large language model through this vertical line. So this chain is now created, the chain of the prompt and the large language model. Exactly similar to the chain which we saw over here, the prompt and the large language model. Okay, when you run this, the chain is created, and now you can just use basic chain.invoke and you just pass the input prompt. So I say that my name is this and what is 1 plus 1. So what is happening here is that this chain is created. I pass the input prompt, which is what is 1 plus 1. So I actually have a figure for here. Yeah, I pass the input prompt what is 1 plus 1. It gets fed as a variable to this prompt template. The prompt template generates a prompt which is passed to the LLM, and then the answer to 1 plus 1 is 2. So that's the answer which we have got from the large language model, and this is the answer now which we have got through the Langchain framework. Now, do you see the advantage of using Langchain here? The main advantage is that it's modular in nature. I can even chain different prompts together here. I can easily change the prompt. So if you have, let's say, a chain of 10 things, you can easily remove one thing from the chain. You can modify one thing. It just becomes very easy to edit and format what you want the large language model to be doing. And that's why Langchain framework is so popular. It's because dealing with chains is easy. It's like removing components is easy, adding components is easy, editing and modifying components is also relatively easy. And that's the main reason why Langchain framework is so popular. So once you run this code on your machine, you will have essentially run your first Langchain program, and that is the start of your journey of developing much more powerful applications. Okay, now the next step which we are going to implement is that we are going to create a chain with multiple prompts to further demonstrate the power of Langchain. So here you see we just had a chain with one prompt, right? But you can chain different prompts together. So what I'm doing here is that I have prompt number 1 here, I have prompt number 2. So what we are doing here is that first we have prompt number 1, it interacts with the large language model, we have an output. That output from prompt number 1 is then passed as an input to prompt number 2. Then prompt number 2 interacts with the large language model, we have an output, and that is the output of this chain with multiple prompts. So you have already started to understand how easy it is to extend this chain logic using Langchain. So here I just showed you 2 prompts, right? What we can do is that we can also have multiple prompts, which is more than 2 prompts. So in this schematic, for example, I am showing 3 prompts: the title prompt, the character prompt, and the story prompt. I am chaining these 3 prompts together. So there is an input, it goes to the first prompt, second prompt, third prompt, and then there is the output. Each of these prompts interact separately with the large language model. Yeah, so each of these prompts interact separately with the large language model. The output of each prompt is passed as an input to the next, and this process continues. Similarly, we can chain how many ever prompts we want. So we are going to actually code this right now, and let's jump into code. So as I told you, we are going to create 3 chains here, right? So the first chain is between the title and the LLM. The second chain is between the character and the LLM. The third chain is between the story and the LLM. So simply what's happening is that we have a summary. We have a summary of a story which we want to generate. And instead of directly telling the LLM to generate the story from the summary, we go in steps. First we generate the title from the summary. Then based on the title, we generate the character. Then based on the title and the character, finally we are going to generate the story. That is the sequential step which we are going to execute. Alright, so here you can see, let's execute the first chain right now, which is the title chain. So first we are going to create again the template, which is the phi3 template. We have the S user, and create a title for a story about summary. So summary is the only input to the entire chain. We have a summary of the story which we want to generate, and the prompt is create a title for a story about summary and only return the title. So then similar to the single chain, we define the title prompt through the prompt template, and then we create our first LLM chain that is called as the title chain. So we define the LLM here, we define the prompt here, and we define the output key to be title. Okay, so this LLM chain we did not see before. We only need to use this LLM chain when we are chaining multiple chains together. So here we are going to chain three chains, right? The title change, the title chain, the character chain, and the story chain. So first we define the title LLM chain, where we have to define the LLM, we have to define the prompt and the output key, which is title in this case. So the first chain has been created. Let's see whether it's working. So I'm going to use title.invoke similar to basic chain.invoke, and then title.invoke, and then you have to pass in the summary, remember? So I passed in the summary, which is a girl that lost her mother, and then I press on this run button, and then you will see that the summary is girl that lost her mother, and the title has been generated, which is Whispers of Love, a journey through grief. Okay, the first chain has successfully executed. Now we are going to the second chain, which is the character. Now remember, when you come to the character, the title output is already there. So you have the title and the summary. You have two things now. Alright, so here again we create a template. Yes, where are we? Yeah, again we create the template, and the template is describe the main character of a story about the summary. And now the story also has this title. We provide the title from the previous output, use only 2 sentences. So we create the character chain over here, like this LLM chain, where again we define LLM is the same LLM. The prompt is now different. The prompt is character prompt, and the output key is character. So we are not printing the output of this, we'll print it towards the end. But after this, the character will also be generated. And then finally we go to the last chain, which is the story chain. Now when we come to the story chain, remember what we have. We have the summary, which is already the input. We have the title, which is the output of the first prompt. And we have the character, which is the output of the second prompt. So when we come to the story prompt, we actually have 3 inputs. We have the summary, we have the title, and we have the character. And then from there, we have to generate the story. So here you can see that again we define a template for creating a story. Then we define the story prompt using prompt template, and then we define the story chain. So again LLM chain, LLM is the same LLM, the prompt is now the story prompt, and output key is story. So here you see we have 3 LLM chains. First the title LLM chain, the character LLM chain, and the story LLM chain. And now to create the full chain, we are going to combine these 3 components together. So now I am doing LLM chain is equal to title with this vertical bar, character, and story. So all of these three components are now combined. This is the power of Langchain. You combined the title LLM chain with the character LLM chain with the story LLM chain. All of these 3 are now combined, and we have one chain which is now called LLM underscore chain. So now this entire thing is comes under the variable LLM underscore chain. That is a combination of the title chain with the character chain with the story chain. All of these 3 chains together lead to the LLM chain. Okay, and now all we have to do is that we have to run this chain, which means we have to pass in the input, which is the summary. So if you look at this entire chain as a whole, the only input which it takes is the summary. So we have to take in this chain and we have to pass the summary, which is the girl that lost her mother. That's the summary. And we do LLM chain.invoke, a girl that lost her mother, which means that now the input is provided and now we only have to look at the output. So then once this chain is invoked, it first gives the input, which is the summary. Then it provides the title, which is a whispers of loss, a mother's embrace fading. Then we have the character. The main character Sarah is a resilient young teenager. And then we have the story, which is Sarah's world crumbled and then as days morphed into weeks, etc. So this entire story is generated. So now you can see that we have chained 3 components together: the title prompt, the character prompt, and the story prompt. The input is passed into this 3 prompt chain and the output has been generated. Just as easily as I have defined these 3 prompts over here, we can do a sequence of 10 prompts, 20 prompts, even 30 prompts. And that's when the power of Langchain starts to demonstrate, because the coding effort which is now needed to write a chain of 20 prompts is not that much. I just have to define additional chains over here. So then here there will be LLM chain 4, then here there will be LLM chain 5, then here there will be LLM chain 6, etc. There will be multiple chains here. And then once the entire chain is defined, then you will just generate the output. And remember, the code for generating the output is just chain.invoke. We also use this .invoke with the single chain, basic chain.invoke. Alright, so now we have covered single prompts and multi-prompt, and I hope you have now started to see the advantages of the modular nature of Langchain. So this is the true power which we are just beginning to explore. In the subsequent lectures, we are going to look at how to add memory to large language models, how to add agentic approaches to large language models, and how to create agents. All of this can be done with Langchain. So what we are exploring is just the tip of the iceberg, but I hope this lecture serves as a motivation for you to explore Langchain further, because it's really one of the most important tools used by LLM researchers right now. That brings us to the end of this lecture. As a quick summary, what we did is we started exploring Langchain today. We saw that the power of Langchain comes from its fundamental building block, which is the chain. What we can do with the chain is essentially link multiple components together. Today we saw how to link prompts to an LLM. We first linked only one prompt to the LLM, and then what we did is we linked multiple prompts to the LLM. And for the linking procedure, we have to define multiple LLM chains, and then we create one final chain. And then the command which we use to get the inference is LLM chain.invoke, and then we type the input text, and then finally we get the output. So thank you everyone. I hope you are liking this approach of the hands-on writing on the whiteboard plus going through the code. I'll be sharing this entire code file with you. In the next lectures, as I said, this is going to get a lot more interesting and advanced. So I look forward to seeing you in the next lecture. Thank you.